This video is on recognizing and extending arithmetic sequences. It's lesson 34 in your book on pages 211 through 215. First, there's some vocabulary that we need to talk about. A sequence is a list of numbers that follow a rule, or basically it's a pattern. So like 2, 4, 6, 8, that's a sequence because you're using only even numbers. A term of the sequence is each number in the sequence. So, for example, if we use that sequence from before, 2, 4, 6, 8, and then on to infinity, 2 is the first term, 4 is the second term, 6 would be the third term, and 8 would be the fourth term, so then 10 would be the fifth, etc. An arithmetic sequence specifically is a sequence that has a constant difference between two consecutive terms. Now that's called the common difference because it's the difference that is common for each pair of terms. Now in that example, 2, 4, 6, 8, 10, the common difference is the difference that between the two terms that is the same for every pair of terms. So the difference between 2 and 4 is 2. The difference between 4 and 6 is 2. The difference between 6 and 8 is 2. The difference between 8 and 10 is 2. So in this case, our common difference is 2. Now remember that if the sequence does not have a common difference, then it is not an arithmetic sequence. Now it could still be a sequence and follow a rule, but in order for it to be arithmetic, the difference between each two consecutive terms needs to be the same. In this example, which needs to be in your book, we are recognizing arithmetic sequences. We want to determine if each sequence is arithmetic, and if it is, find the common difference and the next two terms. Now remember, for it to be arithmetic, the difference between each two consecutive terms needs to be the same. So if you look at the difference between 7 and 12, the difference there is 5. If we look at the difference between 12 and 17, the difference there is 5. If we look at the difference between 17 and 22, the difference is 5. 22 minus 17 is 5, 17 minus 12 is 5, 12 minus 7 is 5. These have a common difference of 5, because the difference between each two consecutive terms is 5. Now they also want us to find the next two terms, so I'll take 22, and to find the next term, I would add the common difference, which is 5, and my next term would be 27. To find the next term, I would take the previous one, 27, and add the common difference again, and get 32. So my common difference here is 5, and my next two terms are 27 and 32. Now let's look at example B. Our first two terms are 3 and 6, and the difference between them is 3. The next terms are 6 and 12, and the difference between 6 and 12 is 6. The next terms are 12 and 24. The difference between those two is 12. Now see how the difference between each next consecutive pair of terms is not the same? Those do not have a common difference. So this one is not arithmetic. We can use this formula to find the next term in an arithmetic sequence, and we use it in the last page. So the formula is a sub n equals a sub n minus 1 plus d. Now, a sub n means the value of the term. So let's see. If we have the example on the last page, 7, 12, 17, 22, etc. And we wanted to find a sub 1. That means the value of the first term. Now, the value of the first term in this pattern is 7. If we wanted to find a sub 2, we want the value of the second term, which is 12. A sub 3 would be the value of the third term, which would be 17, etc., etc. D is the common difference, and a sub n minus 1 means the term before. So if I wanted to find a sub 3 minus 1, that means I want the term before 3, or a sub 2. Now basically what this says is if we want to find a term of the sequence, we can take the term before it and add the common difference. That's the recursive formula. In this example, which needs to be in your notebook, they want us to use the recursive formula to find the first 4 terms of an arithmetic sequence where a sub 1, or the first term, is negative 2, and the common difference is 7. Now that formula that they give us on the last page says that a sub n equals a sub n minus 1 plus d, the common difference. Now in this case, we know our common difference is 7. So I can rewrite this formula to be a sub n equals a sub n minus 1 plus 7. Now I know my first term, right? So that's taken care of. Now if I want to find my second term, a sub 2, I take the term before it, a sub 1, and add 7. Now negative 2 plus 7 is 5, so a sub 2 is 5, or the second term is 5. If I want to find a sub 3, or the third term, I take the term before it, 5, and add 7. So my third term would be 12. And since I want to find the first 4 terms, I need to find a sub 4 also. So I take the term before it, which is 12, and add my common difference, and that gives me 12 plus 7 is 19. So my first 4 terms of this sequence are negative 2, 5, 12, and 19. And of course that sequence can keep going infinitely. Now this equation gives us a way to find the nth term of an arithmetic sequence. Now this is good for when we want to find the 100th term, but we don't already know the 99th. Or we want to find the 75th term, but we don't already know the 74th. So it says, to find a sub n, or some term, you take the first term and add the term number minus 1 times the common difference. Now, what that means is, say we want to find the 63rd term. So I want to find a sub 63. That means the 63rd term. I would take the first term, whatever that is, and add my term number that I'm looking for, which is 63, minus 1 times my common difference. So that n is the term number that you're looking for. Now these examples need to be in your notebook. We're going to use that rule to find nth terms here. Example A says use the rule a sub n equals 6 plus n minus 1 times 2 to find the 4th and 11th terms of the sequence. Now this says a sub n equals 6, that would be the first term, plus n minus 1, so n is the term we're looking for, times 2, which is the common difference. And we want to find the 4th term. Alright, so I want to find the 4th term, which is a sub 4. That means n is 4, because that's the term number I'm trying to find. That equals 6 plus, again, I'm trying to find the 4th term, so n is 4. 4 minus 1 times 2. Now I'm just going to simplify this using order of operations. Of course, I have to do parentheses first. 4 minus 1 is 3. Now I have to do multiplication. So I have 6 plus 6. And that means my 4th term is 12. Alright, so that's how to find the 4th term. Now I'm also going to need to find the 11th term. So in this case, n is 11. To find the 11th term, a sub 11, I use 6 plus, remember n is the term number you're trying to find, so 11 minus 1 times 2. From here, it's just order of operations, so parentheses first. 11 minus 1 is 10. Then multiplication, so 6 plus 20. And 6 plus 20 is 26. So my 11th term is 26. Alright, now in example B, we have to construct our own equation. We want to find the 10th term of the sequence 3, 11, 19, 27, etc., etc. So remember, our formula from the last page is a sub n equals a sub 1 plus n minus 1 times the common difference. Now I know the first term is 3, so I'm going to be able to plug 3 in for a sub 1. Now I need to know the common difference. So let's see, the difference between 3 and 11 is 8. The difference between 11 and 19 is 8. The difference between 19 and 27 is 8. So our common difference is going to be 8. So I can plug 8 in for D right here. Now since I want to find the 10th term, that means n is 10. So to find a sub 10, I take the first term plus term I'm looking for minus 1 times 8. And then I do order of operations. 3 plus 9 times 8. Nine times 8 is 72, so I have 3 plus 72, which is 75. So the 10th term in this sequence is 75. Now we have one more example. This needs to be in your notebook. We want to find the 10th term of this sequence. Now, again, we have the first, second, third, fourth. We could keep adding the common difference until we get to 10. But instead, we're going to create an equation. So I have my general form, a sub n equals the first term plus n minus 1 times the common difference. Now, we need to fill in the first term, which we know is 1/4. And we need to fill in the common difference. So the difference between 1/4 and 3/4 is 1/2. The difference between 3/4 and 5/4 is 1/2. Whoops, that's 1/4. There you go. The difference between 5/4 and 7/4 again is 1/2. So our common difference here is going to be 1/2. Now we need to find the 10th term in this sequence. So that means n is going to be 10. So we have 1/4 plus 10 minus 1 times 1/2. We'll apply order of operations here. We have 1/4 plus 9 times 1/2, which is 1/4 plus 9 over 2, because 9 times 1/2 is 9 over 2, which is going to give us, let's see, 1/4, and that would be 18 over 4. So we would have 19 over 4 as our 10th term. Now, if you need more help with arithmetic sequences, you can see me in class, or you can watch the supplemental video that I will post later.